4.1b. And we're still looking at angles, and we're still looking at some radians. Right. So yesterday we kind of went around and we kind of played around a little bit when it came to those angle measurements, and then switching from degrees to radians and radians to degrees. So we're gonna start with a little circle. Hey, it worked. And then through our circle, just for the fun of it, we're gonna draw like our little X and Y coordinate that goes through there. That's through the center. If it doesn't look like the center to you, just adjust your eyes and call it the center. Right? And so you guys went through and we figured out some of these degrees. So let's say, like if I start, like if I just made this my angle, like so it'd be like 0 degrees. 0 degrees would be 0 radians, right? Can't have anything if there isn't anything. But to get back to this point, I could go all the way around the circle, right? And so that would be how many degrees? 360. And how many radians was 360? Half of that. 2 what? Yep, 2 pi, right? So if I go all the way around, I'm at 2 pi radians. So then if I went 180 degrees, or halfway around, it would be how many radians? 1 pi, right? So this would be pi. Okay. What's 90 degrees going to be? Anybody? 1/2 pi, yep. Or for poops and giggles, we can just write it as like pi over 2, right? Or you can write it as 1/2 pi. So this would be 90 degrees. This would be 180 degrees. How many degrees would it be to right here? So 90 plus 90 is 180, right? Plus another 90 would be 270. Yep. And how many radians would 270 degrees be? What was it? 1/2 pi? Yep. So usually we write, instead of writing it as 1 and 1/2 pi, we just write it as 3 pi over 2, right? 3 over 2 is 1.5, right? It's all good with that. Whoop. And then all of our angles, even if it's just a regular angle or within like a circle, we have quadrants, right? So you got your little X, Y coordinate plane. How many quadrants are there? 4. Good job, right? Which quadrant do we call this one up here? That's quadrant 1. Yep. This one's going to be quadrant 2. Ooh, it's reading my... yeah. Which quadrant's this one going to be? Quadrant 3. Yep. And this last one, come on, you guys all can do this one. What's that one going to be? I'm not telling you. You're so smart. Yep, quadrant 4, right? So when it comes to all of our angles and radians, there's a relationship between the two. Those are like our 4 little basic kind of radians, right? We can kind of figure those ones out, but we can figure out all the ones in between. And then we know like where all of our quadrants are. So sometimes when it comes to angles, we can sit there and figure out like which quadrant it is in. And then we know that if my angle is in quadrant 1, it's going to be between, we're going to go 0, 0, and 90, right? 90 is going to be at the y-axis, but it's got to be between 0 and 90. What degree angles are going to be in quadrant 2? From what to what? So if my angle was like right here, how many degrees-ish would that angle be from here to here? It would have to be more than, but less than. Good job. See? Sometimes I don't know if you guys don't know it or if you're just sleeping on me. You gotta speak up a little bit, right? If my angle is in quadrant 3, what's it going to be between? What degree and what degree? Yeah, 180 and 270, right? And if I'm in quadrant 4, my angles are going to be between 270 and 360. Good job. And then we can even do that going around negative-wise, right? If I wanted to go negative, right, that would be like negative 90 degrees going this way, right? Between here and here would be between negative 90 and negative 180. This one would be between negative 180. Oops, you got two arrows. Between negative 180 and negative 270. And this would be from negative 270 to negative 360, right? So the negatives are just going that clockwise, but going in the opposite direction. Sound good? Alrighty, perfect. So then what happens, we can go through, and if we get a problem, and like say our problem is where our theta equals pi over 4, I can go, oh, I bet you I know where that's going to be. So if I'm pi over 4, we have to know some fractions, right? So if you guys, we can, well, I'm not going to, we can put a 0 in there if you want, right? I'm not putting a 0 in there. If I'm looking for pi over 4, like where's pi over 4 going to be? Is that like less than a pi over 2? Like 1/2 pi? Is a quarter less than half, or is it more than half? It's less, right? So then I know that if I have pi over 4, it has to be in quadrant 1, right? So this is telling me that I'm going to be in quadrant 1, right? And then I'm going to figure out that angle. And we're really good at figuring out angles, right? Pi over 4. What are we going to times it by to turn it into an angle? 100 and, oops, I'm really sloppy today. 180 over pi, right? So the way I remember this one too, when I have my radians, my pi is always in my numerator, right? And ultimately, if I'm going to degrees, when we talk about degrees, we try to get rid of pi. So the only way to get rid of pi is having pi in my denominator. So that's how I kind of remember which way that 180 over pi goes. Is it pi over 180 or 180 over pi, right? So then my pi's are going to cancel. Pi over pi is 1. 4 goes into 4 once. 4 goes into 180, 45, yep. So we're going to get 45 degrees. And is 45 degrees in quadrant 1? Sure is. Right. What if we knew that our theta equaled, let's say, 5 pi over 4? So if we want to try and figure out which quadrant that's in, so is pi over 4 less than or greater than 1/2 pi? Yeah. Or what do we know about 5 over 4? Like what is that ish? More than 1, right? Exactly. So if we know that it's more than 1, we know that it's got to at least be in either quadrant 2, or sorry, quadrant 3 or quadrant 4, right? So our next little stop is 1/2 pi. So is this greater than or less than half?
Greater? Less?
I like less. Yep. Yep. You can always divide those, right? 5 over 4. Right? Remember doing that? If I had 5 over 4 and I wanted to turn it into a decimal, that'd be like 4 divided by 5. 1. Make a decimal, drop down, 1.2, right? And then blah, 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 right? You can always kind of check it that way. Or use your handy dandy calculator, right? So we know then that it's greater than half pi. Is it greater than 2 pi? No. So we know this guy is going to be in quadrant 3. Yep. Does that work? And then we can do the same thing if we had negative angles. Let's say we had negative 3/4 pi, right? So if we're going negative, we almost got to kind of like switch our radians around. Right? Because then if we're thinking negative, like this would be negative pi over 2. This would still be negative pi. Right? The top would now be negative 3 pi over 2. This would be like negative 2 pi, right? Because we're going just in that opposite direction. So a lot of times I just kind of like think of like looking at like the absolute value of it, right? So 3/4 is like 0.75, right? We all good with that one? So that 0.75 is going to be somewhere within here, right? Because this would have given us our negative half. This would have given us negative 1. So we know that the angle is going to be like this-ish, right? So we know this guy is going to be in quadrant 3 as well. And you guys are good on turning those into angles, right? Yep. All right. Anybody want to figure out one of those? Extra credit for the 2 answers of what 5 pi over 4 is as an angle. And then another extra credit for negative 3/4 pi as an angle.
Is it negative 135?
The top or the bottom?
The bottom one?
Negative 135?
And for the top one, I got 225. I got 225.
Man, look at you guys go. Good job, good job. 1, 2, 3, man. Whoosh, getting them all for you. Yeah. Because I'm the giving mood today. Alright. Sound good? Alright. So we have this thing and we kind of showed it to you a little bit yesterday, but we didn't like talk about it. It's these little things called coterminal angles. Oh my, stop. So finding, we're going to go on an adventure. We're going to go looking. So we're going to go finding some coterminal angles. All right. So let's look at our word coterminal. So when we came to angles, what's terminal mean? Yeah, it's the end, right? So it's that little side or that little ray part of the angle that we end with. What does co mean? If you're on a co-ed team, yeah, or more than one, right? Or you're sharing it, right? If you're on this co-ed team, you're like the boys and the girls are sharing the same team type thing, right? So if we're talking about a coterminal angle, we're talking about 2 angles, and guess what those angles are going to do? They're going to share that ending side, right? So if we have our nice little coordinate plane, kind of like that little air line maker. I actually can get some straight lines for once in my life, right? And so, I don't know, let's go with, here's my initial side. Probably shouldn't use green. Oh boy, let's go with blue. Might show up a little better, right? Or not. So here's my initial side, and I'm just gonna go down here. Right? And then technically I got like 2 angles showing up here, right? I have like the angle going around the top and the angle kind of going to the bottom. So if I'm going to go this way, I'm going to go with, I don't know, 240 degrees. You guys all good with 240 degrees? All right, I'm going to say that's 240 degrees. So when it comes to looking at both of those angles that are on this little picture, I still have another angle that's going to go my negative, right, from here to here. And on this one, we share the same initial side, right, but we also share that same end, that co-terminal side. So once I put those together, I technically am going all the way around in a, starts with a C, a circle, right? And a circle is how many degrees? 360, right? So anybody want to guess what that bottom angle is going to be? Almost 120, right? We got the 120. But because we are going clockwise, it's got to be negative 120, right? Very nice. So I usually kind of ignore that positive and negative to figure out what it is. Even if I gave you guys only the bottom angle and I knew it was negative 120, I know absolute value-wise it's got to add up to 360. So I'm going to go, well, 360 minus the 120 is the 240. I'm going counterclockwise, so I know it's got to be the positive, right? All right, let's try another one. Ready to get all, I think you guys got this, so we're going to get all fancy. So I got another little coordinate plane. I got my, oop, oh, don't be doing that on me. I got my little initial side. My initial side is always going to be on that x-axis. I'm going to draw my terminal side going here. But now I'm going to give you guys a crazy angle. So I'm going to start my angle at my initial side, but I'm going to go up and I'm going to go all the way around and come back.
Wouldn't that be like 360, like plus 45, because that would be like splitting in the middle about?
Yeah, yep, good job. So yeah, so I'm going to make it real easy on you guys, and I'm going to say though that like from here to here is 60 degrees, just for poops and giggles, right? So when I want to figure out what my angle is, exactly from here, I go in all the way around to here, that's going to be 360 degrees, right? But then I added how much more to it? 60, right? So technically that whole angle going around is 420 degrees. Does that make sense? Right. But in order to figure out my coterminal, I have actually two ways I can do this. I can only look at my 60 degrees, which I had to give you guys, right? Because if I just look at 60 degrees, does this angle share that same terminal side? Yeah, right? So I could have my 60 degrees. Is there another one I could have? Could I go negative to here, right? And that would be what? Negative 360 degrees, right? So you can get more than one angle when it comes to those coterminals because it's just sharing that same side. And there's really a whole bunch of them because if you really wanted to get all crazy, right, even negative wise, you could go all the way around to 360 and then you could go another 300 and actually have negative 660.